So, very good evening, everyone. Myself, Prateek Mishra, and I welcome you all to the YouTube platform of IMS Gate Academy. This is a session of Gate Score Booster for Environmental Engineering, and this 3 hours is dedicated how to maximize your marks in the first part of environmental engineering, that is your raw water engineering. This is my personal request to all of you. Stay tuned till the end of the video. And effectively, we will going to revise the first half of environmental engineering in very easy way. The thing here that we will going to do is few concepts that are critical concepts. I'll give you an overview about it, and then simultaneously we will solve certain questions which are highly important questions that will actually help you to revise the subject very quickly, especially these important topics that we have. So by these words, I would just like to start this first Gate Score Booster series on environmental engineering. My dear, environmental engineering comprises of water supply engineering, wastewater engineering, air pollution and solid waste management. These are the 4 major segments of environmental engineering in which wastewater engineering has a very critical type of concepts from where very critical questions can be framed. But the easiest area of scoring marks is water supply engineering, air pollution and solid waste management, where you can get very good quality questions and you can solve them easily. If you look into this water supply engineering, it starts from calculating the amount of water required in the community. So the first topic of discussion is the water demand. In water demand, we actually calculate how much amount of water is required in the community. Once we know how much amount of water is required in the community, next thing is we need to identify different sources from where we need to extract this water. So the next topic of discussion comes out to be sources of water. Once we have extracted this water from the source, now we have to do the quality analysis. So the quality analysis of water is done using water quality parameters. After doing the quality analysis of water, then we give treatment to water. Now sir, how much treatment we should give? Depending on the existing quality of raw water and the desired quality of treated water, degree of treatment is given to the raw water. From this statement, we can make sure one thing, that across India, all the treatment plants will have different degrees of treatment based on the quality of existing water. Very good evening, Matan. Then after giving the treatment, the water is stored in a unit called as service reservoir. From there, the water is distributed into the community by different water distribution systems. So moving ahead with this, the first topic of discussion is raw water. Now sir, what is raw water? The water which is extracted from source directly. The water which is not subjected to any artificial treatment is classified as raw water. In order to design the raw water scheme, you need to first calculate few quantities. It starts from the annual draft or annual demand. What is annual draft? The total quantity of water required in a community in 1 year is called as annual draft. It is calculated in terms of volume. Second is annual average daily draft, means the amount of water required in a community in 1 day is called as annual average daily draft, and it is equal to V upon 365. Again, it is calculated in terms of volume. The third quantity that we need to calculate here is called as annual average per capita daily draft. It is the amount of water required in a community in 1 day by one person. Again, it is calculated in terms of volume. The formula is V is the volume, that is annual draft, divided by population of the community, divided by 365. So that is annual average per capita daily draft. So these 3 quantities needs to be calculated for designing any raw water scheme. Now the total quantity of water required in a community is termed as water demand. Based on the different usages of water in the community, we have classified these different demands. It starts from the domestic demand. So domestic demand is the amount of water required for domestic usages. It varies in the range of 135 to 225 liters per capita per day. My dear, wherever you have the confusion or wherever you want to want me to repeat something or wherever you want me to discuss something, kindly comment it in the chat box. Keep commenting in the chat box wherever you start facing problem. So the total water required in the community is termed as water demand. Now based on the usages of water in the community, this total demand is classified into different segments. The first one is the domestic demand. Domestic demand is the amount of water required for different domestic usages, varying in the range of 135 to 225 LPCD. Then you have industrial demand. Name itself says the entire story. The water required for industrial usages varying in the range of 50 to 450 LPCD depending upon the extent of industrialization of a city. If a city has more industries, industrial demand will be more. Then you have institutional demand. So the water required in the community by the different institutes of the community comes under institutional demand varying in the range of 20 to 50 LPCD. Then you have water for public use. Now that is the amount of water required for road cleaning purposes, for gardening the public gardens, varying in the range of 10 to 20 LPCD. Then you have fire demand. So if any fire outbreak happens in the community, then the amount of water required for firefighting comes under fire demand. Then you have thefts and losses. So while distributing the water into the community, if there are certain illegal connections which are illegally utilizing this water, then it is accounted under theft. Due to leakages, the amount of water which is lost comes under losses. So these are the different categories in which total demand is divided. This total demand varies in the range of 250 to 350 LPCD, right? Don't worry about the PDF. You don't have to write anything. But whenever I will going to give you the question, try to solve it as quickly as possible. Chalo, moving ahead with this. Next thing, these are the certain empirical formulas to calculate the fire demand. First one is, as per Government of India manual formula, fire demand is equals to 100 root P, where fire demand is calculated in kiloliters. Whenever you have the empirical formula, units are very important. In which unit you are substituting the values and in which unit you will get the answer. So for Government of India manual formula, if you need to calculate fire demand, it is equal to 100 root P, where P is the population of the community in thousands. So for example, if population of the community is 1 lakh, let me write here. If population of the community is 1 lakh, if population of the community is 1 lakh, then what will be the value of P? Value of P will be 100. Because this 1 lakh is nothing but 100,000. So like that, you need to substitute the value of P here and you will get the fire demand in kiloliters. The next formula for calculating the fire demand is termed as Cutsling's formula, which is equals to 3182 root P, and here the fire demand is calculated in liters per minute in terms of discharge. Next is your Freeman's formula, which says that fire demand Q is equals to 1136 P upon 10 plus 10 in liters per minute. And again here the population P is population of the community in thousands. The next formula for calculating the fire demand is National Board of Fire Underwriters method, in which if the population of the community is less than 2 lakh, then fire demand is calculated as 4637 root P into 1 minus 0.01 root P in liters per minute. Then if a population is more than 2 lakh, then fire demand Q is equals to 5400 liter per minute for first fire, and it is equals to 9100 to 36400 for second fire in liters per minute. Next is your Boston's formula for calculating fire demand, where as per Boston's formula, fire demand Q is equals to 5663 root P, and here also P is the population of the community in thousands and fire demand is calculated in liters per minute. So these are all the empirical relations for calculating the fire demand. Till now, we haven't seen any question from this segment, but there are chances that you may get an easy question from this segment. So remember all these empirical relations for fire demand. Now next is, whenever you supply water into the community, right? So every day you may not require same quantity of water. So from there we understand the concept of fluctuation. Fluctuation in water demand means by how much amount maximum demand varies from the average demand, that is termed as fluctuation. Now fluctuation in water demand is calculated using Goodrich's equation, which gives the percentage ratio of maximum demand to average demand. So percentage ratio of maximum demand to average demand is equals to 180 into T raised to the power minus 0.1. The only limitation of this formula is here you can calculate the fluctuation only above 1 day, 1 and above. So the minimum time that you can enter in this equation is 1 day, where T is the time in days and the minimum value of T is 1 day. So here is a table for fluctuation in water demand. If you talk about hourly demand, fluctuation in demand will be 2.7. For daily demand, it is 1.8. For weekly demand, it is 1.48. For monthly demand, it is 1.28. And for yearly demand is 1. If I talk about what do we mean by this fluctuation in hourly demand, If I am saying fluctuation in hourly demand is 2.7, it means that maximum hourly demand is 2.7 times of average hourly demand. Fluctuation means by how much amount the maximum value varies from the average value. By how much amount the maximum value is more than the average value, that is termed as fluctuation in the water demand. Moving ahead with this, next is, after calculating the fluctuation in water demand, the next topic of discussion comes out to be population forecasting. So if you observe the population of any community, the growth of population of any community depends upon four major factors. First one is the number of births happening in the community. Second is the number of deaths happening in the community. Third one is the number of inward migration happening into the community. And fourth one is the number of outward migration happening into the community. Based on these four major factors, your population of the community will, the growth of population will depend. Now here are the methods of calculating the population or forecasting the population for further decades. So as per arithmetic increase method, population after n decades is equals to P naught. P naught is the last known population plus n into x bar. This is as per arithmetic increase method. In arithmetic increase method, we assume that the increase in population is constant. So this x bar is the average increase in population. As per geometric increase method, population after n decades is equals to P naught into 1 plus r raised to the power n, where again n is the number of decades, P naught is the last known population, and r is the percentage rate of growth of population. So in this method, we assume that the percentage rate of growth of population is constant. Then you have incremental increase method, which gives you the formula that population after n decades is equals to the last known population P naught plus nx bar plus n into n plus 1 by 2 into y bar by 2. N into n plus 1 by 2 into y bar. X bar is average increase in population, whereas y bar is incremental increase in population, right? Apart from this, we have two other methods, that is decreasing rate of growth method, and we have the logistic curve method for population forecasting. You can try this question. I will give you just 2 minutes of time. Do the calculations. Go for it. This is the only good question which is asked from this segment. So please do it quickly. You have 2 minutes of time for it. Go for it. Do it, do it, do it. And keep commenting in the chat box. Keep commenting your answers in the chat box. Go for it. Keep commenting your answers in the chat box. Those of you who have understood the question, you can reply yes. Those of you who have understood the question, kindly reply yes. Go for it. This timer is very important. Go for it, go for it. Okay, let's see this question. So the question says that the present population of the community is 30,000 with an average water consumption of 5,000 meter cube per day. Now, first of all, who will going to tell me what do you understand by this word? Average water consumption of 5,000 meter cube per day. Anyone who can tell me this, what do you mean by average water consumption of 5,000 meter cube per day? So if you observe this question carefully, you will realize that the present population of the community is 30,000 with an average water consumption of 5,000 meter cube per day. Means 30,000 of population is consuming 5,000 meter cube per day of water. So I will write down the present population P naught is 30,000. This 30,000 of population, this 30,000 of population is consuming 5,000 meter cube per day. So water demand for this is 5,000 meter cube per day. This is 5,000 meter cube per day. So from here, can you calculate the amount of water required per capita? So water required per capita will be water required per capita is equal to 5,000 divided by 30,000. This is the amount of water required by one person in one day, and this will be in meter cube per capita per day. This will be in meter cube per capita per day. This is the amount of water required by one person in one day. Okay, let's see this question further. The existing water treatment plant has a design capacity of 7,500 meter cube per day. Means the maximum amount of water that can be treated in the water treatment plant is 7,500 meter cube. So design capacity of water treatment plant is 7,500 meter cube per day. Means if the water treatment plant is running at its capacity, full operational capacity, the maximum amount of water it can treat is 7,500 meter cube per day. Let's see this. It is expected that the population will increase up to 45,000 during the next 20 years. The number of years from now when the plant will reach its design capacity, assuming geometric rate of population growth, will be. Now, what do you understand from this statement? This is a very critical statement in this question, right? Most of the students get confused here itself. This statement is saying, right now, 30,000 population is consuming 5,000 meter cube per day of water. And the total amount of water that can be treated in the water treatment plant is 7,500 meter cube. They are asking in how many years the population will grow from 30,000 to the population which will have this water demand. Right now population is P naught. In how many years this population will grow up to that which will have the total water demand of 7,500 meter cube. So if you want to calculate that population, so population P is equal to amount of water required. This is the design capacity 7,500. This is the design capacity divided by the amount of water used by one person. This is the total amount of water. If you divide it with the amount of water used by one person, you will get that population which will be using 7,500 meter cube per day of water. So please do the calculation. This is population after n years, which is 7,500 divided by 5,000 whole divided by 30,000. So this will be equal to 30,000 into 7,500 divided by 5,000. Please do the calculation. So I think this will be 3 times and this will be 2 times. Please do it. So this will be 15,000. 15 into 3 is 45,000. So population after n years that will consume 7,500 meter cube per day of water is 45,000. Now the question becomes very simple. In the question they are asking in how many years the population will grow from 30,000 to 45,000. And they have also mentioned that the population is growing by geometric rate of growth. So we can use this formula that population after n years is equal to P naught into 1 plus R upon 100 raised to the power n. But sir, N I need to find out, for that I require R. Now how to calculate this R? Very good, very good, very good, Kirti. Now sir, how to calculate this value of R? In order to calculate this value of R, they have given you one more added information, that it is expected that the population will increase up to 45,000 in next 20 years. Now the question is simplified. It has become so simple. In 20 years, the population will become 45,000. So coincidentally, the data is as such that in next 20 years, directly you are getting 45,000 as the population. So here, instead of calculating this using this formula, you can directly write down in next 20 years, the population will grow up to 45,000. In next 20 years, population will grow up to 25,000. Population will grow up to 45,000, sorry. Population will grow up to 45,000. So what will be the answer? The answer will be 20 years. That is 2 decades. Very good, Kirti, very good. Okay, so this is how you need to solve the question. So for what will be the answer? In how many years the plant will reach its design capacity? Answer is 20 years. Okay, chalo, moving ahead with this to the next question. Okay, after this, actually this topic, right, water demand, population forecasting, we hardly got 3 questions from this area in last 33 years. Okay, so that becomes a very easy segment. After that, we have a common portion which is common in environmental engineering, geotechnical engineering, and then you have water resource engineering, and that is your sources of water. My dear, first of all, you need to understand that how many different types of sources we have. We have 2 types of sources, surface sources and the subsurface sources. Okay. What is your answer, Kirti? 22.47. What you are saying? It is 22.47. This one. This will be 15,000. 15 into 3 will be 45,000. So directly you know that in next 20 years, the population will reach up to 45,000. Okay. You not need to apply this formula also. Directly you can comment. Okay, moving ahead with this, next topic of discussion is sources of water. My dear, there are 2 types of sources of water, subsurface source and the surface source. In surface source, basically we have rivers, lakes, ponds, seas and oceans. In subsurface source, we have aquifers. Now, in order to extract this underground water, 2 parameters are very important. First one is the porosity. Porosity tells us how much amount of water can be stored in the soil. Porosity is simply the ratio of volume of voids to the total volume of the soil medium. Now we have 2 different types of soil, fine-grained soil and coarse-grained soil. So obviously, in coarse-grained soil, the porosity will be less because total volume of voids is comparatively less in coarse-grained soil as compared to fine-grained soil. So porosity basically explains us the amount of water that can be stored. It explains us about the amount of water that can be stored, in soil medium. Now sir, why we want to know this? For example, you constructed a house. Okay, you want to construct a very big project. So first thing that you will look is how much amount of water is available, because that water should serve your life of the construction, right? If you are constructing any building, then for next 50-60 years, the water that should be present inside the ground should serve your purpose. That is why we want to know about how much quantity of water is stored. So that can be analyzed using porosity of the soil medium. So basically, porosity of the soil medium tells us about the amount of water that can be stored in the soil medium. It is calculated by calculating volume of voids to the total volume of soil medium. Which soil will be having more porosity? Fine-grained soil will have more porosity than coarse-grained soil. Next thing is, the next factor that affects the extraction of this underground water is permeability. So usually we define permeability as the ease with which water can flow through the interconnecting voids. But here you need to understand one thing. When the water will be flowing through the interconnecting voids, this is your soil medium. when the water will be flowing through the interconnecting voids. While this water is flowing through the interconnecting voids, the surface of the soil medium will apply friction over this flowing water. The surface of the soil medium will apply friction over the flowing water. More friction means less permeability. More friction means this water will have, or this water will experience more hindrance while flowing through the interconnecting voids. Means this permeability is the function of the surface area of the soil medium. And the property that we use to define the surface area of the soil medium is called as specific surface area. Now, specific surface area can be defined either the total surface area divided by weight of the soil medium, or total surface area divided by the volume of the soil medium. Soil solids, sorry. Total surface area of the soil solids divided by the weight of the soil solids, or total surface area of the soil solids divided by the volume of the soil solids. In either way, you can define the specific surface area. Now, you have to understand one thing. If specific surface area of the soil medium is more, means that water which is flowing through the interconnecting void will experience more friction. More friction means less permeability. That is why we say that fine grained soil has lesser permeability than coarse grained soil. Reason is, for fine grained soil, a specific surface area is more as compared to the coarse grained soil. So usually we see that permeability is the rate of flow of water through the soil medium. It can be understood by the frictional resistance offered by the soil medium. If frictional resistance offered by the soil medium is more, permeability will be less. If frictional resistance offered will be less, permeability will be more. So these two factors actually help you to decide how easily you can fetch the amount of water and how long you can fetch this water. So whenever we are analyzing the soil for extraction of this underground water, majorly we use porosity of the soil medium and permeability of the soil medium. So porosity tells us about the amount of water that can be extracted from the soil medium, whereas permeability tells us about how easily the water can be extracted. The ease with which water can be extracted from soil medium. Ease with which water can be extracted from the soil medium. The ease with which water can be extracted from the soil medium is defined by the permeability of the soil medium. Moving ahead with this, these are the important formulas. First one is the average velocity of flow. V is equals to K into I, where K is the permeability and I is the hydraulic gradient. I is defined as the head loss per unit length of flow. Hydraulic gradient I is defined as head loss per unit length of flow. Per unit length of flow. This average velocity is not the actual velocity of flow. When the water will be seeping through the soil medium, it will not seep through the average velocity. In fact, it will seep through the seepage velocity. Seepage velocity is the actual velocity of flow, which is equal to the average velocity divided by porosity and degree of saturation. Okay, discharge Q is equals to KIA, where K is the permeability of the soil medium, I is the hydraulic gradient, and A is the cross-sectional area of the soil medium. So any time if a question comes in the exam that you need to find out in how much time an inert tracer can reach from one end to the another, you will going to use the seepage velocity. If you need to find out in how much time water will reach from point A to point B, again you will use seepage velocity, because seepage velocity is the actual velocity of flow. Chalo, moving ahead with this, try this question. Again, I'll give you just 2 minutes of time. Go for it. A very important question. If you study hydrology irrigation, this topic is common in well hydraulics. You read this topic as well hydraulics. Chalo, go for this. You have 2 minutes of time. Go for it. And everyone keep commenting your answers. Meanwhile. Keep commenting your answers. And please don't forget to share the channel, share the link with your friends. Keep commenting, go for it. Go for it, go for it. It's a very, very important subject and we are dealing it with full discussion. Go for it. Many years the same question was repeated for 2 marks. Go for it. Keep commenting your answers in the chat box. So question says that two wells are situated at a distance of 2 kilometers from each other in the soil medium, indicating the head difference of 2.5 meter in the direction of flow. Chalo sir, visualize this first. There are two wells which are situated in the soil medium like this. This is well number 1 and this is well number 2, which are situated in the soil medium, and the water is flowing from well 1 to well 2. So these are two wells which are situated in the soil medium and the water is flowing from well 1 to well 2. The water is flowing from well 1 to well 2. Check this out. So these are two wells situated in the soil medium, well number 1 and well number 2. And the water is flowing from well 1 to well 2 like this. Now my dear, when the water will flow from well 1 to well 2, first of all tell me by which velocity this water will going to flow. Very good, very good. Very good, Kirtan. By which velocity this water will going to flow from well 1 to well 2? So the answer is the seepage velocity. So the velocity by which this water flows from well 1 to well 2 is the seepage velocity, right? The distance between two wells is given to you as how much? The distance between two wells is 2 kilometers. So this distance between two wells is given to you as 2 kilometers. The distance between two wells is given to you as 2 kilometers. Means the length of flow is given to you as 2 meters. Next thing is the head difference is also known to you. The head difference between the level of water in the two wells is also known to you. This head difference is also known to you. And this head difference is given to you as 2.5 meter. So when the water is flowing from well 1 to well 2, the head difference is given to you as 2.5 meter. This head difference is 2.5 meter. Okay, sir. Now the question is saying that if the porosity and permeability of the soil medium is 25% and 50 meter per day respectively, then compute the time taken by inert tracer. Now sir, what is this? Inert tracer. Inert tracer is nothing but a dye. Inert tracer, you can visualize this as a dye which does not get dissolved with the water. Very good. Very good. Very good, Kirti. Very good, Kirtan. So inert tracer is a kind of dye which does not get dissolved with water. So the question is asking, if you insert an inert tracer here, in how much time this inert tracer will reach to well number 2? So if you are inserting an inert tracer here, in how much time it will going to reach to well number 2? Now this question becomes so simple. It's simple question like time is equals to distance by speed. That is what you need to do. Distance is already given to you as 2 kilometers. So inert tracer has to travel a distance of 2 kilometers. By which velocity this inert tracer will going to travel? It will going to travel by the seepage velocity, because this inert tracer will be moving along with the flow. So the time in which inert tracer will reach from well 2, from well 1 can be calculated like this. So the time in which inert tracer will reach from well 2 to well 1 can be calculated like this. So this is equals to distance upon seepage velocity. Now distance is given to you as 2 kilometers. So I will keep this as in meters divided by Vs. Now sir, how to calculate Vs? For calculating Vs, somewhat data is given to you. Porosity is 25% and permeability is 50 meter per day. Porosity is 25% and permeability is 50 meter per day, right? Sir, but I know only one formula, that seepage velocity is equal to average velocity divided by porosity and degree of saturation. Degree of saturation is 1 because soil is completely saturated when the flow is taking place. So here S is equals to 1. Now sir, seepage velocity Vs is equal to, this discharge velocity can be written as K into I divided by N. You know the value of K, you know the value of N. Now it's time to calculate hydraulic gradient. Hydraulic gradient is nothing but the head loss divided by the length of flow. So head loss is given to you as 2.5 meter and length of flow is 2 kilometers. So please calculate this. So seepage velocity Vs is equal to permeability, which is 50 meter per day. Please write down the units. Units are very important. Porosity is given to you as 25%. So I will write this as 0.25. Hydraulic gradient I will write down as head loss. Head loss is 2.5 meter divided by length of flow, which is 2000 meters. So this is your seepage velocity. Please calculate this and tell me what is the answer for seepage velocity. Please calculate this seepage velocity and tell me what will be the answer for seepage velocity. So this will be 10 times. So this is 200. So 50 by 200 is 1 by 4. And 1 by 4 is 0.5 meter per day. 0.75 meter per day. Just check this. Is it correct? Just check the seepage velocity and tell me, is it correct? 0.75 meter per day. Let me also do it with the calculator. So 50 into 2.5 divided by 0.25 divided by 2000. Yeah. Oh, 0.25, not 75. 1 by 4 is 0.25. This is 0.25 meter per day. Now, once you know the seepage velocity, you have to just substitute in this expression to calculate the time. So, time t is equal to 2000 divided by the seepage velocity, which is given to you as 0.25. You have calculated as 0.25. Calculate the number of days. What will be the answer for this? 2000 divided by 0.25. So this will be equal to 8000 days. This is coming out as 8000 days. So in 8000 days, your inner tracer will reach from well 1 to well 2. Now usually in this varieties of question, after calculating this value, some of the students starts doubting their answers. Never do that. Believe in your calculations. If you have done this correctly, then this will be your final answer. Okay. So in 8000 days, so approximately how many years? So just divide this by 365. So this is 365. So this will be 21.92 years. This will be 21.92 years. In this much time, your inner tracer will reach from well 1 to well 2. Okay. So again, a very important varieties of question. Multiple times asked for environment, for hydrology, irrigation. So keep a check on this type of questions. Okay. Chalo, moving ahead with this. The next is, okay. So we have understood two factors which will help us in extracting the underground water. First one is the porosity, which tells us about how much amount of water that will be extracted. Sorry, how much amount of water that can be stored. Yeah, very good, Kirti. Correct answer. Porosity tells us about how much amount of water that can be stored, and permeability tells us about how easily we can extract that water. Now, if the water is flowing under the action of gravity, all the water will not flow out from the soil medium. Some water will be adsorbed over the surface of the soil medium. So if the flow is taking place in the soil medium, complete water will not flow out from the soil medium. Now sir, how to check how much amount of water will flow out, how much amount of water will be adsorbed or retained in the soil medium? In order to analyzing that thing, we have two factors which is called as specific yield and specific retention. Specific yield tells us about how much amount of water flows out under the action of gravity. And specific retention tells us about how much amount of water will be retained against the action of gravity, how much amount of water will be adsorbed over the surface of the soil medium. So specific yield is the volume of water drained to the total volume of medium drained, whereas specific retention is the volume of water retained against the action of gravity divided by the volume of medium drained. So these two factors actually help us in deciding how much amount of water will flow out under the action of gravity and how much amount of water will be retained against the action of gravity. So specific retention and specific yield is equal to N into S. This is a very important relation, specific yield plus specific retention. Specific yield plus specific retention is equal to N into S. A very, very important expression. Again, from this expression, we have seen multiple times the questions have been asked in the examination, right? Where N is the porosity of the soil medium and S is the degree of saturation. Chalo, with this concept, try this. Try this question. I am taking up all the important varieties of questions whose chances of getting asked in the examination is the highest. In fact, these questions are also helping you to recall your concepts and revise them quickly. Please solve it. Solve it, solve it. And all of you keep commenting your answers. All of you understanding the concepts. If you are understanding the concepts, if this session is helping you out, just give me a thumbs up. If it is helping you out, just give me a thumbs up. Do it, do it, do it. Just show me your presence. Give me a thumbs up if this session is helping you out. And if any of your friends are also preparing for the same exam, you can also just share the session. Thank you, Kirtan. Thank you, Akshat. Thank you. If any of your friends is also preparing for the same exam, kindly share the session with them. Thank you, Kirti. Chalo, please solve this question. It's a very important variety of question. So let's see. Question says that water table of an aquifer drops by 200 centimeter over an area of 75 hectares. Visualize this situation in your mind. So this is your ground level. From this ground level, this is the initial position of groundwater table. This is initial position of groundwater table. This is initial position of groundwater table, and after pumping, this level of water has dropped by 200 centimeters. This level of water has dropped by 200 centimeters like this. This level of water has dropped by 200 centimeters. This level of water has dropped by 200 centimeters. Okay. The porosity and specific retention of the aquifer medium are 25 and 5% respectively. So porosity N is given to you as 25%. N is 25%. And you have a specific retention, gamma R is given to you as 5%. Okay, sir. Calculate the change in groundwater storage. Now, sir, what is this change in groundwater storage? if you are extracting water from the ground surface, sorry, if you are extracting this underground water, how much amount of water you have extracted that have caused the fall of 200 centimeter in this ground level. Means simply they are asking you how much amount of water you have drained out. So whenever this type of question comes and this thing is written, change in groundwater storage. Change in groundwater storage simply means volume of water drained. Volume of water drained. Change in groundwater storage simply means volume of water drained. Means how much amount of water is drained out, how much amount of water extracted. Now sir, in order to calculate this volume of water drained, you require a specific yield. So point number 1 is calculate a specific yield of the soil medium. For that you already have a specific retention and the porosity. So specific yield of the soil medium can be calculated like this. So specific yield plus specific retention, specific yield plus specific retention is equal to N into S. Degree of saturation of the soil medium is 1. Soil is completely saturated when this fall in groundwater table is taking place. So calculate this specific yield. Calculate the specific yield, gamma S plus 0.05 is equal to N, which is 0.25. Please calculate this specific yield. Get me the answer of specific yield. All of you keep commenting your answers. Keep calculating and keep commenting your answers. What is the amount of specific yield? Please tell me the answer for this. Specific yield. Calculate this specific yield. So this is 0.25 minus 0.05. So I think the specific yield will be 0.2. This is your specific yield. Now once you know the value of specific yield, you can use the expression specific yield gamma S is equal to volume of medium drained, volume of water drained, which is VD, divided by the volume of medium drained, V. So what is the value of VD? VD is the fall in groundwater table is 200 centimeter and it has taken place over 75 hectares of area. So VD, we need to find out V, volume of medium drained, will be 200 into 75. Now sir, you need to convert this hectare into meters and this centimeter into meters. So I will write down gamma S is 0.2, VD we need to find out, divided by V. V is this 200 centimeter will be how many meters? 200 centimeters will be 2 meters. So 2 into 75 into 10 raised to power 4. Calculate this value of VD. Yeah, very good Kirti, very good Kirtan. Please calculate the value of this VD. Volume of water drained. Please calculate this VD. Please calculate this VD. Get me the value of VD. Meanwhile, I'll also do the calculation. So this will be 0.4. So 0.4 into 75. So 30 into 10 raised to power 4. So this will be 30 into 10 raised to power 4, 1, 2, 3, 4 meter cube. All of you just quickly confirm you are getting the same answer or you are getting something different. Just confirm me once. Same answer or different? You have 33 into 10 raised to power 5 meter cube. The answer to this question is 3 into 10 raised to power 5 meter cube. Just give me a thumbs up if you are getting the same answer. 3 into 10 raised to power 5 meter cube. If you are getting the same answer, just give me a thumbs up quickly. And if you are getting some other answers, you can also write in the chat box. Please do it. Okay. So this is how you need to deal with this question. Whenever you are asked to calculate change in groundwater storage, it simply means you need to find out how much amount of water drained out from the soil medium. That is what we mean by volume of water drained. And for calculating this volume of water drained, you need to find out the specific yield. Very good, Akshat. Very good, Kirtan. Very good, Kirti. Chalo. Moving ahead with this, next is after analyzing the sources of water, right? The next thing is we need to extract this water, and after extracting the water, directly we don't take this water into use. We have to analyze the quality of water. So the water quality is analyzed using water quality parameters, which are of three types. You have physical water quality parameter, chemical water quality parameter, and biological water quality parameter. All these three parameters are used to analyze the quality of water. Now, sir, if you observe this physical water quality parameters, so all those water quality parameters which can be felt or sensed by any of our senses are classified as physical water quality parameter. Example is suspended solids. You can see suspended solids in water. Turbidity, you can see turbidity in water. Color can be seen. Taste and odor can be felt, and again temperature can be felt. So all these are your physical water quality parameters. Then you have chemical water quality parameters, which affects the chemical property of water. All these chemical water quality parameters will be present in dissolved form, right? They can't be seen through the naked eyes. So first of all, if you look into this chemical water quality parameter, dissolved solid is a chemical water quality parameter and suspended solid is a physical water quality parameter. None of these physical water quality parameter will affect the chemical quality of water. So the chemical water quality parameter starts from dissolved solids, alkalinity, pH, hardness, nitrogen content, chloride content, fluoride content. Then you have dissolved gases and metals. In all these chemical water quality parameters, if you are observing this segment, this is the most important segment from where a very good quality question can be framed. And the reason why I am saying a very good quality question is you will get the question from the basics. And if you are strong in the basics of chemistry, definitely you can make out questions from these three segments. Okay. And then lastly, you have the biological water quality parameter in which you check for the pathogens. Pathogens are the disease causing microorganisms. So now you don't directly go to check pathogens. You calculate the colonies of coliforms. You calculate the colonies of coliforms. Now, sir, what are coliforms? Coliforms are non-disease causing microorganisms. Colonies of coliforms are counted, and the colonies of coliforms are used to find out the colonies of pathogens. So, if in any interview they ask you, pathogens are calculated directly, answer is no. Pathogens are calculated using coliforms. Coliforms are non-disease causing microorganisms. So the colonies of coliforms are calibrated with the colonies of pathogens in order to get the quantity of disease causing microorganisms present in your water sample. Chalo, one by one, let's see that. First of all, if I talk about suspended solids, so everything we have learned, this is just a revision series, okay? We will going to see questions directly after this. So I have prepared a summary table for you. This is a summary table which will actually help you to get multiple select questions correctly. So first one is suspended solids. It is determined using gravimetric technique. Now the permissible limit of suspended solids as per NEPA is 30 milligram per liter. This is National Environment Protection Act gives you the value of permissible value of suspended solids, which is 30 milligram per liter. Second one is turbidity. Now sir, we have four different methods to determine turbidity. Turbidity rod method, Jackson's turbidity meter method, Baylis turbid meter method, and then you have nephelometer. Out of all these four methods, initial three methods, turbidity rod method, Jackson's turbidity meter method, and Baylis turbid meter method will give you turbidity in silica turbidity units. So the standard samples are prepared by dissolving 1 milligram of Fuller's earth or SiO2 or silica dioxide to get some turbidity in 1 liter of distilled water. So the amount of turbidity caused by 1 milligram of Fuller's earth in 1 liter of distilled water is classified as 1 STU of turbidity, silica turbidity unit. On the other hand, the last method, which is called as nephelometer. In nephelometer, the turbidity is measured using formazine or in NTUs. Standard samples are prepared by dissolving 1 milligram of formazine in 1 liter of distilled water. So the amount of turbidity caused by 1 milligram of formazine in 1 liter of distilled water is termed as 1 NTU or 1 FTU of turbidity. NTU means Nephlo turbidity unit. FTU means formazine turbidity unit, same thing. Okay. Nowadays, which unit we are using? We are using NTU. So most important test for us is the nephlometer test, right? But I have given you the idea that we have 4 different methods to measure turbidity of the water sample. First one is turbidity rod method, Jackson's turbidity meter method, then you have Baylis turbid meter method, and lastly you have the nephlometer. Okay, sir. So either this is STU and this is NTU. The permissible limit of turbidity is 1 NTU. And cause for rejection value. Now, sir, what is cause for rejection value? In the emergency situation where you cannot provide full treatment to the water, then water up to 5 NTU of turbidity can be consumed for short duration. That is termed as cause for rejection value. So, cause for rejection value for turbidity is 5 NTU. Cause for rejection value for turbidity is 5 NTU. Now next is you have color. Color is again measured by color matching technique, and here the standard samples are prepared using platinum in a form of chloroplatinate ion. Thank you so much, Richa. Here the color is developed in the form of platinum in the form of chloroplatinate ion. The instrument used is called as tintometer. The acceptable limit for color is 5 TCU. And cause for rejection value is 25 TCU. Cause for rejection value for color is 25 TCU. Next you have taste and odor. Taste and odor, the method used to measure taste and odor is dilution, and the equipment used is termed as osmoscope. The acceptable limit for taste and odor is 1 TON, and cause for rejection value is 3 TON. So cause for rejection value is 3 TON. Cause for rejection value for taste and odor is 3 TON, right? Then you have temperature, and basically temperature is measured by thermometer. The permissible range of temperature is 10 to 25 degrees Celsius. Means whenever we supply water to the community, we maintain the temperature in the range of 10 to 25 degrees Celsius. Chalo, by this, attempt this question. This intentionally I haven't explained you how to measure suspended solids, all those things, because this question will give you the proper idea how to do the test for measuring suspended solids, total solids and your dissolved solids. Please go for it. You have 2 minutes of time. Go for it and keep commenting your answers. Go for it. Go for it and solve this. Please go for it and solve this. Do it quickly. Any answers? Any answers? Any answers from your side? Anything that you have calculated? Any answers from your side that you have calculated? So question says that following observations were being made on a raw water sample. Following observations were being made on a raw water sample. A crucible was dried to a constant mass of 58.68 grams. Means the empty weight of the crucible W1 is given to you as 58.68 grams. Now see this. So empty weight of the crucible is empty weight of crucible is given to you as 58.68 grams. Okay, sir. Next thing is 50 ml of well mixed sample was taken in the crucible. So the volume of water taken is 50 ml. Volume of water sample is 50 ml. Volume of water sample is equal to 50 ml, right? Now, sir, just visualize this diagram in your mind. So there is a crucible like this. There is a crucible like this. In this crucible, you have poured 50 ml of water. In this crucible, 50 ml of water is poured. Now, this 50 ml of water contains solids. Very good, Kirti. I'm expecting those two are the correct answers. 50 ml of water is poured in this crucible like this. (50 ml of water is poured in this crucible. Now this crucible, this water contains solids like this. So these are the suspended solids which can be seen from the naked eyes, and then there will be dissolved solids which are not seen, which cannot be seen from the naked eyes. Then there will be some dissolved solids like this, which cannot be seen from the naked eyes, right? Now, sir, what is happening here? This crucible is kept inside the oven at 104 degrees Celsius for 24 hours. First of all, tell me, what will happen if we keep this crucible inside the oven at 104 degrees Celsius for 24 hours? Can you tell me? When you keep this crucible inside oven at 104 degrees Celsius for 24 hours, then all the water which is present in this crucible will going to dry up. And you will be left with only total solids. Means both suspended and dissolved solids will be left out and all the water will be evaporated. So after 24 hours, when you take out this water sample, this crucible, you are only left with total solids, means suspended and dissolved solids. All the water has evaporated. All the water has evaporated from the system and you are only left with this total solids, right? So this is a crucible in which all the water is evaporated, and now this crucible only contains total solids. The weight of crucible and total solids is given to you as 61.89 grams. You can see that. The crucible with the sample was dried to a constant mass of 61.89 grams, means weight of crucible plus total solids. Weight of crucible plus total solids. Weight of crucible plus total solids. I name this as W2. It is given to you as 61.89 grams. This is 61.89 grams, right? So empty weight of the crucible, this is W1, and the weight of crucible with total solids is 61.89 grams. Now first thing that you need to do is calculate the amount of total solids present here. Calculate the concentration of total solids. So total solids concentration is weight of crucible plus total solids, that is W2, minus empty weight of crucible. So this will going to give you weight of total solids present in this crucible. Now these total solids are present in 50 ml of the water sample. So divide by 50, multiply by 1000 will going to give you the amount of total solids present in 1 liter of the water sample. Please do the calculation. So total solid concentration TS is equal to W2 is 61.89. This is 61.89 minus W1. W1 is 58.68. This is 58.68 divided by 50 into 1000. Divided by 50 into 1000. Please get me this total solid concentration, and this will come out in gram per liter. This much amount of total solids will be present in gram per liter. Please calculate this. So this is 61.89 minus 58.68 divided by 50 into 1000. So this will be 64.2 gram per liter. So total solid concentration is 64.2 gram per liter. Okay, sir. So first step is done. Now next step is, very good Kirti, very good. 64.2 gram per liter. Now next is, the crucible with the dried sample was placed in the muffle furnace at 600 degrees Celsius and after cooling with residue as 60.02 grams. Now what do we mean by this? This oven dried sample of total solids, is kept in muffle furnace. This oven dried sample of total solids is kept in muffle furnace at 600 degrees Celsius. They haven't mentioned duration, but what they have mentioned is, at such a high temperature of these total solids, volatile total solids will going to vaporize and you will be left with only fixed total solids. So at such a high temperature, all the volatile solids will going to vaporize and you will be left with only fixed total solids. So this crucible will now only contain fixed total solids. All the volatile solids will going to vaporize. Volatile total solids will vaporize. So volatile solids will vaporize. Volatile solids will vaporize, and now this will only contain fixed solids. So this W3 is nothing but weight of crucible plus weight of fixed solids. This W3 is weight of crucible plus weight of fixed solids. So weight of crucible so W3 is weight of crucible plus fixed solids is given to you as, this is given to you as 60.02 grams. 60.02 grams. So W3 is given to you as 60.02 grams. Now from here, first of all, calculate the fixed solid concentration. So fixed solid concentration will be, W3 minus empty weight of the crucible, which is W1. Now this much amount of fixed solid is present in 50 ml of the sample. So divide by 50, multiply by 1000. This will going to give you the fixed solid concentration on the water sample. So this is 60.02 minus W1. W1 is given to you as 58.68. So this is minus 58.68 divided by 50, multiply by 1000. Can you quickly give me this answer? fixed solid concentration. This will also come out in gram per liter. Please calculate this and tell me the answer. So this is 60.02 minus 58.68 divided by 50 multiply by 1000. So this will be 26.8. So fixed total solids is 26.8 gram per liter. Just check this out. Are you also getting the same answer? Just check this out. Are you getting the same answer? Very good, Richa. Very good, Kirti. So this is how much? Just calculate this. 26.8. Very good, Kirti. All of you just quickly answer this, confirm whether it is correct or not. All of you are fine with this? 26.8 gram per liter. Okay. Now next is, they are asking you to find out, compute the organic fraction of solids present in the raw water in percentage. You need to find out the fraction of organic total solids present in this water sample. So sir, you already know the value of total solids. You know the value of fixed total solids. Now you can calculate the value of organic total solids. So we can use this relation. Total solids is the sum of organic total solids plus fixed total solids. So total solids you have calculated as 64.2 grams. So total solids is 64.2 grams. Organic total solids you need to find out, and fixed total solids is 26.8. Get me the value of organic total solids from here. Please tell me the value of organic total solids. Calculate this quickly. So this is 64.2 minus 26.8. So this will be 37.4. Organic total solids is 37.4 gram per liter. Just quickly confirm this. Organic total solids will be how much? 37.4. Very good, Kirti. Kirti has directly calculated this percentage fraction. Can you tell me the value of organic total solids? Kindly confirm this. This is 37.4. Yeah, very good. Now calculate the percentage fraction of organic solids. So percentage fraction of organic solids percentage fraction of organic total solids is equal to organic total solids divided by total solids into 100. This is the percentage fraction of organic total solids. So do this. 37.4 divided by 64.2. 37.4 divided by 64.2 into 100. Please do this. 37.4 divided by 64.2. 37.4 divided by 64.2 into 100. So this will be 58.25%. So percentage fraction of organic total solids is 58.25%. So usually you can see an easy question can be framed from this segment. But in order to solve this easy question, you should know the test. Again, I just quickly brief you on this. So total solids, how to find out total solids? You take the water sample, keep it in oven at 104 degrees Celsius for 24 hours. All the water will evaporate, and whatever amount of total solids you get, you take the weight of that total solids, divide it with the volume of water sample in ml, multiply it with 1000, you will get the total solid concentration. Now these total solids are of two types, organic and inorganic. In order to calculate the quantities of these two types of total solids, you can keep the oven dried total solid sample into the muffle furnace at 550 to 600 degrees Celsius for the duration of 2 hours. At such a high duration and such a high temperature, all the volatile solids will going to vaporize and you will be left out with inorganic total solids, right? So you can very well calculate, yeah Kirti, it's absolutely correct, 58.25 is the correct answer. This is the correct answer. All of you are agreeing with me, this same answer you are getting? Chalo, quickly reply yes or no. Just give me a thumbs up if you are getting the same answer. If you have that energy, if you have that zeal to complete entire raw water engineering till 9 o'clock, so just show me some energy so that I can feel motivated to give you best of the content in very less time. Show me that energy so that we can complete all these things very easily. It can help you to retain for longer duration of time, and probably after this session, you will be feeling quite confident, especially in the first part of your environmental engineering, that is your raw water engineering. So show me some energy on that. Keep calculating like this. With that, let's move ahead. Next is the chemical water quality parameters. I told you in chemical water quality parameters, there are three very important areas from where the questions can be asked. Very good, Akshat. First one is the alkalinity, second one is the pH, and third one is the hardness. So first of all, let's check this out. So total solids is the sum of suspended solids plus your dissolved solids. Very good, Kirtan. Others also show some energy. There are so many students watching live. Kindly show your energy so that even I feel confident whatever I am doing here is actually helping you out. So total solids is measured by gravimetric technique. Dissolved solids, on the other hand, is also measured by gravimetric technique. But there is one easier way to measure approximately how much amount of total dissolved solid is there. That is by measuring the specific conductance of water. By measuring the specific conductance of water, you can calculate the concentration of only those dissolved solids which are present in ionic form. Now the dissolved solid concentration is equal to the specific conductance of water multiplied by a factor of 0.65 to get dissolved solid concentration in milligram per liter. Okay, sir. Now next parameter is your alkalinity. My dear, alkalinity is the acid neutralizing tendency of water. How much amount of acid can be neutralized by water is the property which is termed as alkalinity. Now, if you have to neutralize the acid, basically you have to add any anion. Any anion can have the property of neutralizing the acid. Acid is H plus ions. Okay. So, alkalinity is the property of the anions. Alkalinity, anions. Alkalinity, anions. Alkalinity means anions. It is the property of negatively charged ions or anions. It is the acid neutralizing tendency of water. It is the acid neutralizing tendency of water which is caused by the anions. Alkalinity is measured by titration, and in this the titrant used is 0.02 normal H2SO4. Titrant used is 0.02 normal H2SO4, and the indicators used are phenolphthalein and methyl orange. And while discussing this in the class, I told you that majorly there are three types of alkalinity. First one is the caustic alkalinity, second one is the carbonate alkalinity, and third one is the bicarbonate alkalinity. Alkalinity is the property caused by all the anions, but majorly three anions: OH minus ions, CO3 minus ions, and HCO3 minus ions. So when you start the titration, in the first stage of titration, phenolphthalein indicator is used, and this phenolphthalein indicator gives you the color change at a pH of 8.2. In this first stage of titration, the color changes from pink to colorless, and in the first stage of titration, all the caustic alkalinity and half of carbonate alkalinity is neutralized. Means OH alkalinity caused by OH minus ions and half of the alkalinity caused by bicarbonate ions are neutralized. Now after that, you will add methyl orange as the second indicator. This methyl orange indicator will give you the color change at a pH of 4.5. The color change is from yellow to orange red. Remember, methyl orange, yellow to orange red is the color change. And in the second stage of titration, another half of carbonate alkalinity and remaining bicarbonate alkalinity will be neutralized. And then we have seen different cases regarding the volume of acid used in stage 1 and stage 2. So if volume of acid used in stage 1 is P and the volume of acid, total acid used is M. Based on that, we have analyzed several cases, and based on that, we have also found out which alkalinity will be predominating in which cases. The acceptable limit for alkalinity in water is 200 milligram per liter as CaCO3, and cause for rejection value is 600 milligram per liter as CaCO3. Cause for rejection value is 600 milligram per liter as CaCO3. Okay, one more data I have missed here. For total solids, acceptable limit is 500 milligram per liter, and cause for rejection value is 2000 milligram per liter as CaCO3. Sorry, 2000 milligram per liter. This is for total solids. Okay, very good. pH is a scale to measure acidity of the water. pH is a scale to measure acidity of the water. Very good, Kirti. I have just added few details, and Kirti is also telling me that, sir, when this color change of methyl orange happens from yellow to orange red, actually methyl orange is entering into its working range, which is 4.4 to 2.8. And in the first stage of this phenolphthalein, the color changes from pink to colorless, where phenolphthalein comes out of the working range, where the working range of phenolphthalein is 10 to 8.5. Okay, sir. Now next, chemical water quality parameter is pH. pH means the scale to measure acidity or basicity of the water. pH is negative log to the base 10 of H plus ion concentration, and here the H plus ion concentration is kept in moles per liter. pH is measured using potentiometer using calomel electrodes. Now, sir, important thing about calomel electrode is they are only sensitive towards H plus and OH minus ions. They are only sensitive towards H plus and OH minus ions, and usually the water that we supply, we keep that pH in the range of 7 to 8.5. That is the permissible limit. Okay. Cause for rejection value will be 6.5 to 9.2. Cause for rejection value will be 6.5 to 9.2, means in that range also you can supply water into the community for very less duration. Then you have next important chemical water quality parameter, which is termed as hardness. My dear, hardness means the ability of the water to reduce the foam forming ability of the soap is termed as hardness. So basically this is the definition, all of us know, but we want to solve question through these slides. So sir, how do we remember hardness? Hardness is the property caused by multivalent cations, means the property induced by +2 or +3 charge cations is termed as hardness. Now sir, how many types of multivalent cations can be present? There can be calcium 2+, magnesium 2+, iron Fe 2+ and 3+, aluminium 3+, strontium 3+. So many ions are there, copper 2+. So all these cations which are having +2 or +3 charge will induce hardness to the water. My dear, remember this, alkalinity is anions, hardness is multivalent cations. Keep this thing in your mind. What is hardness? Hardness is multivalent cations. Now this hardness is again measured by titration. Here the titrant used is EDTA, ethylene diamine tetraacetic acid, and the indicator used is EBT, which is called as eriochrome black tea. Now when you perform the titration, the color change that you will get will be from wine red to blue black. Now sir, why this color change is taking place? Because the moment you will add eriochrome black tea into the water containing hardness, this eriochrome black tea will form a complex with hardness which is wine red in color. Now the moment you will start the titration, EDTA will start replacing this EBT from that complex, and EBT will be removed from that complex and it stays in the system, and ideally EBT has blue-black color. So when all the EBT is removed from the complex, you will get the color change as blue-black. The permissible limit for hardness is again 200 milligram per liter, and cause for rejection value is 600 milligram per liter. But especially water which is supplied into the community, the hardness is kept in the range of 75 to 115 milligram per liter. Still I am telling you acceptable limit 200 milligram per liter as CaCO3. Cause for rejection value 600 milligram per liter as CaCO3. But the water which is supplied into the community is having the hardness between 75 to 115 milligram per liter. Now next is your chloride content. Now sir, these are very easy things. Quickly just we'll go through this. Chloride content measured by titration. Titrant uses silver nitrate and the indicator used is potassium chromate. The acceptable limit for chloride content is 200 milligram per liter. One more thing here, alkalinity is of two types. Basically three types: caustic alkalinity, carbonate alkalinity and bicarbonate alkalinity. Similarly, hardness will be of two types: carbonate hardness and the non-carbonate hardness. The minimum of alkalinity and total hardness, will be equal to carbonate hardness. So like that you can also calculate the other values. Okay, moving ahead with this. Next one is the fluoride content. Now sir, it is a very tricky parameter. What happens with fluoride is, up to 1 milligram per liter of fluoride is required for proper growth of our teeth. But if same fluoride content exceeds 1.5 milligram per liter, it starts decolorizing our teeth, leading to a disease which is called as mottling of teeth. If same fluoride content exceeds 5 milligram per liter in your water sample and you are consuming that water, then it leads to a disease which is termed as bone fluorosis. So the acceptable limit or the range of fluoride that should be present in water lies in the range of 1 to 1.5 milligram per liter. Very, very important. Fluoride is measured by color matching technique and color is developed using zirconium ion and alizarin. Next one is the nitrogen content. Now my dear, nitrogen in your water sample can be present in 4 different forms. First one is called as free ammonia. Free ammonia basically indicates how much amount of simple organic matter is present in your water sample. Second one is organic ammonia. Organic ammonia especially tells you the amount of complex organic matter present in your water sample. Then you have nitrite. The presence of nitrite indicates partially decomposed organic matter in your water sample. Now, if your water sample contains partially decomposed organic matter, it will also going to have microorganisms. And if you start consuming this water, you may feel waterborne diseases. You may have waterborne diseases. That is why for nitrite, the permissible limit is 0 milligram per liter. We don't want any nitrite to be present in the water sample. Then you have last nitrate. My dear, nitrate is the stable end product of anaerobic decomposition. Presence of nitrate indicates that all the decomposition is completed, right? But there is one problem with this nitrate as well. Up to 45 milligram per liter of nitrate will not cause any harm. But if it exceeds 45 milligram per liter and if such water is consumed by newly born babies, infants, it will lead to a disease termed as methyboglobemia or blue baby disease. We have discussed in detail about that. I told you how that disease is caused. So permissible limits are written here. For free ammonia, the acceptable limit is 0.5 milligram per liter. For organic ammonia, it is 0.3 milligram per liter. And then nitrite, it is 0 milligram per liter. And for nitrate, it is 45 milligram per liter. So these are all the values, and free ammonia is determined by simple boiling. Organic ammonia is determined by adding a strong oxidizing agent like KMNO4 and again boiling the sample. And then after that you measure the extra amount of ammonia which is liberated, which is termed as organic ammonia. For measuring nitrite, you will use color matching technique, and color is developed by sulfonic acid and naphthamine. For nitrate, it is again measured by color matching technique, and color is developed using phenol disulfonic acid and potassium hydroxide. So these are the important points regarding your chemical water quality parameter. Please go with this question. Again, a very important question from basic chemistry. Go for it. 2 minutes of time for you. Go for it. Go for it. Go for it. And show some energy. Keep showing your energy in the chat box. It maintains my energy as well. Do it, do it, do it. Do it, do it, do it. Keep doing it. And keep showing your energy in the chat box. Keep showing your energy that you are still there. You are still fighting for a rank. We are reading for a rank. We are not reading to qualify the GATE exam. If we have put in 8-9 months of our life in certain thing, we need to get the result. So keep showing that energy so that it also keeps me motivating for taking this session. Go ahead. So the question says that 170 milligram of HNO3 strong acid is added in water, bringing the final volume to 1 liter. So in simple words, 1 liter of water, in that you are adding 170 milligram of HNO3. Very good. Very good, very good. Consider the atomic weight of hydrogen, nitrogen, oxygen as 1 gram per mole, 14 gram per mole and 16 gram per mole respectively. The pH of water is, ignoring dissociation of water. Just see how simple question is made complicated by simply adding these values or these languages. What you need to find out? You need to find out the pH of the water sample. In simple words, what do you mean by pH of the water sample? pH of the water sample means negative log to the base 10 of H plus ion concentration. And here the H plus ion concentration should be kept in moles per liter. Here H plus ion concentration should be kept in moles per liter. Now sir, how to get this H plus ion concentration? So for getting H plus ion concentration, you are given 170 milligram of HNO3. So when you dissolve HNO3 in water, it dissociates into H plus ion plus NO3 minus ion. This is the dissociation of HNO3. So whenever HNO3 is dissolved in water, it dissociates into H plus ion and NO3 minus ion. Now from this equation I can write down 1 mole of HNO3. 1 mole of HNO3 gives 1 mole of H plus ion. Gives 1 mole of H plus ion. 1 mole of HNO3 gives 1 mole of H plus ion. Now sir, calculate the number of moles of HNO3 that you have added here. Number of moles of HNO3 is 170 into 10 raised power minus 3, because this is in milligrams. 170 is in milligrams, so I have multiplied 10 raised power minus 3. So this will be grams. Given weight by the molecular weight of HNO3 will give you the number of moles of HNO3. So given weight is 170 into 10 raised power minus 3. Molecular weight will be hydrogen 1, nitrogen 14 and oxygen 16 into 3. Hydrogen 1, nitrogen 14 plus oxygen 16 into 3. This will be the molecular weight of HNO3 in grams. And this ratio will going to give you the number of moles of HNO3. Calculate this. This is number of moles of HNO3. So if these are the number of moles of HNO3, means same number of moles of H plus ions will also be present. So now you got the number of moles of H plus ion. These many number of moles of H plus ions are present in how much water? It is present in 1 liter of water. It is present in 1 liter of water. So I will write down number of moles of H plus ion concentration is given to you as 170 into 10 raised power minus 3. So this is 170 into 10 raised power minus 3 divided by, what is the sum here? So this is 15. 15 plus 48 will be how much? Just do 15 plus 48. So 15 plus 48 will be 63. So this will be 170 into 10 raised power minus 3 divided by 63. Please solve this. So 170 by 63. So this will be 2.6984. 2.6984 into 10 raised power minus 3 moles per liter. So this is H plus ion concentration. Now you can calculate pH. pH is negative log to the base 10 of 2.6984 into 10 raised power minus 3. So this can be written as minus log to the base 10 of 2.6984 minus log to the base 10 of 10 raised power minus 3. Right. So when your bases, this base is same with your number inside, this power will come out in front. So this will be how much? This will be negative log of 2.6984. So this will be minus 0.431. Okay, so this power will come out. You have log to the base 10 of 10. So this will be plus 3 log to the base 10 of 10. So log to the base 10 of 10 will be 1. So you can just subtract this 3 minus 0.431. So this will be 2.569. So pH is 2.569. This is the pH of the water sample. Just check with the options which one is matching. So 2.57, option C will be the correct answer for this, right? Just quickly get me yes or no whether you are getting same answer or not. Just tell me whether you are getting same answer or not. Same answer for this, all of you? All of you are having the same answer, just confirm yes or no. Same answer for pH, 2.569 can be written as 2.57. Yeah, I think you are getting the same answer. So pH will be this. Okay. So moving ahead with the next question, try this one. It's a very simple question. Quickly give me your answer. I am not writing anything or I am not giving you any timer. Just quickly read the question and get me the answer. All of you go through the question and read and give me the answer. Very good, Kirtan. Yeah, very good, Kirti. You have already solved. Very good, beta. Now in quick speed, just get me the answer of this question. This should not take much time. The same varieties of question is asked for 2 marks in your exam. Do it quickly. Do it. The alkalinity and the hardness of the water sample is 300 milligram per liter and 400 milligram per liter. And then you need to find out the concentration of carbonate and non-carbonate hardness. Easiest question of all time. Very good, Kirtan. Very good. Easiest question of all time. The alkalinity and the hardness of the water sample are 300 milligram per liter and 400 milligram per liter. You know the best thing for this question. Some of the student will write ki data insufficient to calculate carbonate and non-carbonate hardness. But we know the note point. And what does our note point says? Our note point says that minimum of total hardness or alkalinity. Minimum of total hardness or alkalinity. Minimum of total hardness or alkalinity is equal to carbonate hardness. minimum of total hardness and alkalinity is equal to carbonate hardness. It's equal to carbonate hardness, right? So just compare alkalinity and total hardness. So alkalinity is given to you as 300 milligram per liter and total hardness is 400 milligram per liter. So total hardness is 400 milligram per liter as CaCO3 and alkalinity is 300 milligram per liter as CaCO3. So which one is minimum? So you can see that total alkalinity is minimum 300. So I will say carbonate hardness is equals to 300 milligram per liter as CaCO3. So carbonate hardness will be 300 milligram per liter as CaCO3. Now sir, you got the value of carbonate hardness. Now calculate the non-carbonate hardness. So you know that total hardness is equals to carbonate hardness plus non-carbonate hardness. So total hardness is 400, carbonate hardness is 300. So not will be non-carbonate hardness. So non-carbonate hardness will come out as 100 milligram per liter as CaCO3. Non-carbonate hardness will come out as 100 milligram per liter as CaCO3. Non-carbonate hardness will come out as 100 milligram per liter as CaCO3. So what will be the correct answer? Carbonate hardness is 300 and non-carbonate hardness is 100. So option D is the correct answer for this question. Okay? Option D. Kirtan has said it correctly. Kirti has said it correctly. Very good. Very good. All of you are just show me that energy. There are like 3-4 students who are continuously answering, showing their zeal. What about others? Keep showing your energy, right? We are here to revise the content in very less time. And I'm telling you, such a challenging task can only be done if you have that kind of temperament, if you had that kind of energy, you have that kind of zeal to finish the entire thing in very less time. For that, your energy is also required. With that, let's move to the next question, a very, very important one. Take your time and solve this. The water sample containing all these ions, atomic weight is given to you. You need to find out total hardness and the non-carbonate hardness of the water sample. Chalo, do this. You need to find out total hardness and the non-carbonate hardness of the water sample. Take 3 minutes of time. Go for it. Go for it. Go for it. And keep posting your answers. Keep posting your answers. Yeah, Roshan is also there. Very good. Keep answering, Roshan. Keep learning. Keep answering. Go for it. It's a very important question. Crack this question out. Crack this question quickly. Crack this question. Keep answering. Keep answering, all of you. Keep answering, keep answering. Keep answering the question. The water sample contains following ions, right? You have sodium ion, calcium ion, magnesium ion, aluminium ion, then you have bicarbonate ion and chloride ion. Atomic weight of sodium, calcium, magnesium, aluminium, hydrogen, carbon, oxygen, chloride is given to you. Calculate the total hardness and the non-carbonate hardness of the water sample. Now, my dear students, I have told you that several times that alkalinity is the property caused by all the anions, right? But while calculating the alkalinity here, you need to consider the major ion causing alkalinity. So only HCO3 minus ion will be considered for calculating alkalinity because it is a major ion which causes alkalinity. Similarly, for calculating the total hardness, again, total hardness will be caused by all the multivalent cations. But in the examination for calculating total hardness, only consider total hardness because of these major ions. That is, calcium and magnesium ions are the major ions causing total hardness in the water sample. So you need to calculate total hardness. Let's calculate. Total hardness is equal to number of gram equivalents of calcium ions plus magnesium ions. Number of gram equivalents of calcium ions plus magnesium ions multiplied by equivalent weight of CaCO3 multiplied by equivalent weight of CaCO3 multiplied by equivalent weight of CaCO3, and that is the total hardness of the water sample. Now, sir, how to calculate number of gram equivalents of calcium ion? So, number of gram equivalents of calcium ion is the given weight of calcium ion, which is 50 milligram per liter. So, I will write down this as 50 into 10 raised power minus 3 divided by the equivalent weight of calcium. Now, equivalent weight of calcium will be atomic weight of calcium divided by valency of calcium. So, valency of calcium is 2. So, that will be 40 by 2. That will be 40 by 2. This is grams, this is also grams. And this will going to give you the number of gram equivalents of calcium. Similarly, write down the number of gram equivalents of magnesium. So, the given weight of magnesium is 48 milligram per liter. So, this is 48 milligrams. So, milligram means 10 raised power minus 3 divided by the equivalent weight of magnesium. Now, sir, how to calculate equivalent weight of magnesium? So, molecular weight of magnesium is 24, atomic weight of magnesium is 24 divided by valency of magnesium, which is 2. So, 24 by 2 will be the equivalent weight of magnesium. Given weight by equivalent weight will give you number of gram equivalents. Given weight by equivalent weight will give you number of gram equivalents. Now, this needs to be multiplied with equivalent weight of CaCO3, which is equal to molecular weight of CaCO3 divided by the valency of CaCO3, which is 2, and this will going to give you the concentration of hardness in gram per liter as CaCO3. Please calculate total hardness concentration in gram per liter. Please calculate this value. Sir, aluminium is also multivalent cation. Yes, beta, that is what I was saying. Aluminium is a multivalent cation, but for calculating total hardness, we will calculate using only the major ions. Same goes with the anions. You have chloride, again a anion. But for calculating alkalinity, we will only calculate alkalinity caused by this major ion of HCO3 minus. Right? Chalo, do this. Do this calculation. So this will be how much? This will be 50 by 20. So 50 by 20 plus This will be 48 by 12, that is 4 into 50. So total hardness will be 325. 325. Total hardness will be 325 into 10 raised to power minus 3 gram per liter as CaCO3. So this 10 raised to power minus 3 and gram will be milligram. So total hardness will be equal to 325 milligram per liter as CaCO3. This is 325 milligram per liter as CaCO3. Now after this, you need to find out total alkalinity. So total alkalinity is equal to number of gram equivalents of HCO3 minus ion multiplied by equivalent weight of CaCO3 multiplied by equivalent weight of CaCO3. So number of gram equivalents of HCO3 minus ion will be the given weight, which is 122 milligram per liter. So I will write this down as 122 into 10 raised to power minus 3 divided by the equivalent weight of HCO3 minus ion. So hydrogen is 1, carbon is 12, oxygen is 16 into 3. So this is the molecular weight divided by valency of HCO3 minus ion, which is 1. So this will going to give you the equivalent weight. So sand and silt is answering 325. Very good. Kirti is answering KS. Okay. Kirti is answering, 325 only. Now get me the value of alkalinity. So this is the number of gram equivalents of HCO3 minus ion multiplied by the equivalent weight of CaCO3. So equivalent weight of CaCO3 is the molecular weight of CaCO3 divided by valency, and this will going to give you the concentration in gram per liter as CaCO3. Get me the concentration of alkalinity. So alkalinity will be 100 milligram per liter. Okay. So this will be how much? This will be 61. Okay. So 122 by 61 will be 2. This 2 and 2 will cancel out. So this will be 100 into 10 raised to power minus 3 gram per liter. So alkalinity is equal to 100 into 10 raised to power minus 3 gram per liter as CaCO3. So this 10 raised to power minus 3 in gram will be milligram. So alkalinity will be equal to 100 milligram per liter as CaCO3. Now sir, you know the value of alkalinity. You know the value of total hardness. You can calculate the other types of hardness, that is carbonate and non-carbonate hardness. So I will write down minimum of total hardness and alkalinity is equal to carbonate hardness. So which one is minimum? Total hardness is 325 and alkalinity is 100. So you have carbonate hardness is 100 milligram per liter as CaCO3. Now you know the value of carbonate hardness, you can calculate non-carbonate hardness. So total hardness is the sum of carbonate hardness plus non-carbonate hardness. Total hardness is 325. Carbonate hardness is 100 plus non-carbonate hardness. So non-carbonate hardness will be 225 milligram per liter as CaCO3. So non-carbonate hardness will be this will be the value of non-carbonate hardness. So in the question you need to find out the total hardness and the non-carbonate hardness. So this is how you need to proceed. Okay. Yeah, very good, very good. Sir, can you please write your name? Sand and silt is quite an odd name or quite an odd handle name. I think you are in love with soil. That is why sand and silt. So non-carbonate hardness is 225 milligram per liter as CaCO3. Okay. So basically when you have this varieties of question, so what you need to do is first you need to find out total hardness, then you need to find out total alkalinity. Minimum of them will be carbonate hardness, and then using total hardness is equals to carbonate hardness plus non-carbonate hardness, you can calculate the non-carbonate hardness. Chalo, moving ahead with this, try this question. I think I have one more. Yeah, go for this. Try this. These are the questions from basic chemistry that student actually leaves in the exam. I don't want you to leave such type of questions. Those are very easy questions. Go for it. 2 minutes of time for you. Go for it. Hello. Intentionally, I have taken this question to give you this idea. These are like one of the very favorite category of questions that are asked in GATE exam. Reason is, if you look from your point of view, these questions can be highly conceptual questions. But from my point of view, in fact, the point of view of the examiner who will be framing your questions, these questions can be very easily made. That is why this is one of the very favorite category. And for some students, those who don't know the basics, this will be a very complicated category as well. So whenever you are asked to find out, right now in this question, you are asked to calculate carbon content. So start looking out where carbon is present. So from the chemical analysis of the water sample, following results were obtained. So you have first compound C2H6. So again carbon is present here. Then you have another compound CO2. Again carbon is present here. Then you have oxygen, no carbon present. Ammonia, no carbon present. So these two compounds are irrelevant for us. I need to find out total carbon content. Any content is asked. Let me just give you the generalized step. Please make it as a note. Any content, any compound content, any compound content, any compound content is equal to number of moles of the compound, number of moles of the compound, number of moles of the compound multiply by its atomic weight. Multiply by its atomic weight. Multiply by its atomic weight. Instead of compound, I should write atom. Any atom content. Right now you are carbon you are having. So any atom content is equal to number of moles of the atom, number of moles of the atom multiplied by the atomic weight. Number of moles of the atom multiply by the atomic weight. Keep this thing in your mind and you will never miss out on this special or easy category of question that is asked here. Now sir, how to deal with this question? Wait, we are dealing with that question. And we will deal this question in such a way that this method stays in your mind forever. You will never going to miss out on this question after this point onwards. What you need to do? First compound containing carbon. Here you need to find out carbon content. First compound containing carbon, calculate number of moles of that compound. So number of moles of C2H6 is equal to given weight of C2H6. So wherever milligram is there, you multiply it with 10 raised power minus 3 in order to avoid confusion. So this is your weight of C2H6 in grams. So 20 into 10 raised power minus 3 in grams divided by the molecular weight of C2H6, which will be again in grams. So molecular weight of C2H6 will be 12 into 2 plus hydrogen 1 into 6. And this will also be in grams. Calculate the number of moles of C2H6. Get me this answer. So this will be 12 into 2, 24. 24 plus 6 will be 30. So 20 by 30, 2 by 3. So this will be 2 by 3 into 10 raised power minus 6. Sorry, 10 raised power minus 3. Number of moles of C2H6 is present. Now next. Second compound containing carbon is CO2. Calculate number of moles of CO2. Calculate number of moles of CO2. Number of moles of CO2. Number of moles of CO2 is given weight of CO2, which is 5 milligrams. So 5 into 10 raised power minus 3 grams divided by the molecular weight of CO2. So carbon is 12, oxygen is 16 into 2. Okay. And this will also be in grams. Calculate this number of moles. Calculate this number of moles of CO2. So this will be 32 plus 12, 44. So 5 by 44. This will be 0.113 or 0.114. 114. This will be the number of moles of CO2. Now sir, you have to find out number of moles of carbon, because you need to find out carbon content. Now how to do it? Are simple. 1 mole of C2H6 contains 2 moles of carbon. So this many moles of C2H6 will contain how much amount of carbon? Into 2. Similarly, 1 mole of CO2 will contain 1 mole of carbon. So if these many moles of CO2 are present, then how many moles of carbon will be present here? Same number of moles. So you have to count the total number of moles of carbon present. So I will write here a statement. Just 1 second. So 1 mole of C2H6. 1 mole of C2H6 contains 2 moles of carbon. Contains 2 moles of carbon. So 2 by 3 into 10 raised power minus 3. So 2 by 3 into 10 raised power minus 3 moles of C2H6 contains 2 into 2 by 3 into 10 raised power minus 3 moles of carbon. Similarly, 1 mole of CO2, 1 mole of CO2 contains 1 mole of carbon. So 0.114 moles of CO2, 0.114 moles of CO2 will contain 0.114 moles of carbon. So just count the total number of moles of carbon. So you have one set of moles of carbon here and one set of moles of carbon here. Just add both of them to calculate total number of moles of carbon. So carbon content is equal to total number of moles of carbon, which is equal to 4 by 3 into 10 raised power minus 3 plus 0.114. These are the total number of moles of carbon multiplied by the atomic weight of carbon, which is 12. This will going to give you the answer in gram per liter. Units are very important, my dear. If you miss out on the units, then these units will create a severe problem for you. You have substituted this atomic weight in grams, so this will come out in gram per liter. Get me the value in gram per liter first and then convert it into milligram per liter. Please do it. So this will be 4 by 3. So this will be 1.384 gram per liter. This will be 1.384 gram per liter. And when you convert this into milligram per liter, you can multiply it with 1000. So this will be how much? 1384 milligram per liter. Just check, is this correct? So 5 by 44. Okay, here 10 raised power minus 3 is also there. So here also there will be 10 raised power minus 3. So this will be 0.114 into 10 raised power minus 3. This will be 0.114 into 10 raised power minus 3 moles of carbon. So this will be 0.114 into 10 raised power minus 3 into 12. So just do this calculation and this will going to give you the concentration in gram per liter. So this will be, you can take out 10 raised power minus 3 and 10 raised power minus 3 gram will be milligram. So 4 by 3 plus 0.114 into 12. So this will be 17.368. 17.368 milligram per liter. All of you just quickly confirm whether this answer is correct or not. All of you just quickly confirm this, whether this answer is correct or not. This answer is correct. Just quickly confirm. This is correct. Kindly check and confirm. Okay, so like this you need to solve. Whenever you need to find out content of any atom, you need to find out the total number of moles of that atom multiplied with the atomic weight. Yeah, very good. Yeah, so Sand and Silt has also answered it. Kirti is also saying yes. So 17.368. Chalo, moving ahead with this. This is the next question. Please try it. The question says that a 500 ml sample of water has initial pH of 10. A 500 sample of water has initial pH of 10, 45 ml of 0.02 normal H2SO4 is required to titrate the sample to a pH of 4.5. Okay. Now, when you see this type of questions, you have to recall the entire test that you have done. Basically, this is the test to determine alkalinity of the water sample. When you add 0.02 normal H2SO4 as a titrant, that is when you are determining the alkalinity of the water sample, right? So, if I simply plot you a graph between pH variation and volume of acid used, so it will be like this. Initially, you start at a pH of 10. Initially, you start at a pH of 10, then first and second stage of titration like this. And at the end of second stage of titration, the pH of the water sample is 4.5. Okay, sir. This pH will be 4.5. This pH is 4.5. And here you will measure the total volume of acid used, which is mml. So this is the plot between pH and volume of acid used. Volume of acid used. pH and volume of acid used, right? Now, what is given in the question? Question says that a 500 ml sample of water has initial pH of 10 and 45 ml of 0.02 normal H2SO4 is required to titrate the sample to a pH of 4.5. The total alkalinity of the water sample in milligram per liter as CaCO3 is. So now, sir, let me write down first. Volume of water sample is volume of water sample is 500 ml and volume of acid used is 45 ml. Means the value of M is given to you as 45 ml. Now, from here to here, whatever acid you have added, that acid is used to neutralize all the three types of alkalinity: caustic alkalinity, carbonate alkalinity and bicarbonate alkalinity. So, simply this 45 ml of the acid is used to neutralize all the alkalinity present in the water sample. Now, sir, after this titration, we know that the number of gram equivalents of acid used will be equal to the number of gram equivalents of alkalinity. And once we know the number of gram equivalents of alkalinity, we can multiply it with the equivalent weight of CaCO3 to calculate the concentration of alkalinity, right? So, number of gram equivalents of acid used is number of gram equivalents of acid used. Number of gram equivalents of acid used is normality of the acid, which is 0.02, multiplied by volume of the acid. So this is 10 raised to power minus 3. Okay, I'll write here. So this is equal to normality of the acid 0.02 multiplied by volume of the acid. Now since volume is in ml, so I will take 10 raised to power minus 3. Now these many gram of this many volume of acid is used for 500 ml of the sample. So for 1 liter of the sample, you need to divide by 500 and multiply it with 1000. So this will going to give you the number of gram equivalents of acid used. Don't solve it. Number of gram equivalents of acid used will be equal to number of gram equivalents of alkalinity. Number of gram equivalents of acid used. Number of gram equivalents of acid used. Number of gram equivalents of acid used is equal to number of gram equivalents of alkalinity. Number of gram equivalents of alkalinity, right? So from here you can calculate number of gram equivalents of alkalinity. Same, you have to simply multiply it with the equivalent weight of CaCO3. So total alkalinity of the water sample will be total alkalinity of the water sample will be number of gram equivalents of alkalinity, which is this 0.02 into 45 into 10 raised to power minus 3 divided by 500 multiply by 1000 into the equivalent weight of CaCO3. So equivalent weight of CaCO3 will be 100 by 2, molecular weight by valency. So this will going to give you the concentration in gram per liter as CaCO3. Get me the concentration in milligram per liter as CaCO3. Please solve this. Kirti is saying 90 milligram per liter. Very good. So just solve this and get me the answer. Please solve this and get me the answer in milligram per liter as CaCO3. So this will be 0.02 into 2 into 45 into 50. So this will be, total alkalinity will be 90 milligram per liter as, so total alkalinity will be equal to 90 milligram per liter as CaCO3. This will be the total alkalinity of your water sample, which will be 90 milligram per liter as CaCO3. All of you are getting the same answer? Any confusion to anyone here? So especially these type of questions, easy questions, but again, this question can only be solved by those students who know the test of determining alkalinity, right? So that is why everything that we study in the class is important from your exam point of view. From even the slightest of the concept, a very good quality question can be framed. Okay. So moving ahead with this, try this question. The question says that effluent from industry A has a pH of 4.5. The effluent from industry B has double the hydroxyl ion concentration than effluent from industry A. The pH of the effluent from industry B will be, so the pH of water sample coming out from industry A is given to you. Check this out. So from industry A, pH is 4.5. Now they are talking about hydroxyl ion concentration. So I can also find out the OH ion concentration. I can use this pH plus POH is equal to 14. pH is 4.5. So 4.5 plus POH is equal to 14. Get me the answer for POH. So I think POH will be 9.5. POH will be 9.5. Just check everyone and tell me. POH will be coming out as 9.5. Now once you have POH, get me the OH minus ion concentration for industry A. So I can write down POH is negative log to the base 10 of OH minus ion concentration. That is POH. And the value of POH is 9.5 for industry A. You can substitute here. So this is 9.5 is equal to negative log to the base 10 of OH minus ion concentration. So OH minus ion concentration for industry A. OH minus ion concentration for industry A will be 10 raised to power minus 9.5 moles per liter. So OH minus ion concentration for industry A will be 10 raised to power minus 9.5 moles per liter. That is your OH minus ion concentration for industry A. Now they are saying that the effluent from industry B has double the hydroxyl ion concentration than the effluent from industry A. Means OH minus ion concentration for industry B is twice the OH minus ion concentration for industry A. OH minus ion concentration for industry B is twice the OH minus ion concentration for industry A. Substitute the values. So OH minus ion concentration for industry B is equal to 2 times of 10 raised to power minus 9.5 moles per liter. This is OH minus ion concentration for industry B. Get me the value of POH for industry B. So for industry B, POH will be equal to negative log to the base 10 of OH minus ion concentration for industry B, and this is in moles per liter. The above one, the OH minus ion concentration that you have calculated is in moles per liter. Do this calculation and get me the value of POH for industry B. So 4.8 is the pH for industry A. Not 4.8 beta, 4.5. Acha, 4.8 is the pH of industry B. Okay. Get me this value of POH for industry B. So POH for industry B is negative log to the base 10 of 2 into 10 raised to power minus 9.5 moles per liter. Calculate this. Get me the value of this POH for industry B. So POH for industry will be how much? Please check this out. So POH for industry B is 9.19. Okay. So this is 9.19. Now calculate pH for industry B. So pH plus POH is equal to 14. So pH for industry B is equal to 14 minus 9.19. So pH for industry B will be how much? pH for industry B will be how much? This will be, I think, 4 something. Please calculate this. Very good, Akshat. Very good, Kirti. Kindly calculate pH for industry B. It is 4.8. Okay. So pH for industry B, how it can be 4.8? 4.8 or 4.08? 4.81. This is 9.19. So this is 4.81. That is pH for your industry B, 4.81. Okay, so like that, again, you can have a very fantastic question in your examination related to pH. Let's move ahead with this. Try this question. Okay. Now, basically, whatever the major varieties of questions that can be framed from the previous segment of chemical water quality parameters, I have told you, right? Now, after this, the next category is the biological water quality parameters. In that biological water quality parameter, we need to find out the quantity of pathogens present in the water sample. In that, we have multiple tests. We have a sterile membrane technique. Then we have multiple tube fermentation test, which is also called as MPN test, most probable MPN, most probable number. Right. So in that case, a question is given to us. A water sample is analyzed for coliform organisms by the multiple tube fermentation test. For the sample, dilution set is 0.01, 0.001 and 0.0001. This is the dilution prepared, right? Dilution prepared is this. The number of positive test results tubes out of 5 for each were obtained as 4 to 2. Number of positive tubes for first dilution is 4, second dilution is 2 and third dilution is also 2. Now, sir, the most probable number of coliforms organism for the above result to be obtained using the following MPN index is. So, sir, whenever this type of question comes from the MPN, these are the easiest question, right? Always remember this. Final MPN value is equal to MPN value from calibration chart. MPN value from the calibration chart multiplied by the first dilution of calibration chart multiplied by the first dilution of calibration chart multiplied by the first dilution of calibration chart divided by the first dilution of test performed. Divided by the first dilution of test performed. Divided by the first dilution of test performed, right? So this is how you need to report the final MPN value. So final MPN value is equals to MPN value from the calibration chart multiplied by the first dilution of the calibration chart divided by the first dilution of the test performed. Okay, now sir, how we need to do this question? Simply observe the number of positive tubes and observe this table without looking anything else. Just find out this combination where this combination of number of positive tubes is there. So you can check out first is not there, second is not there, but this third combination has the same number of positive tubes. Corresponding to this third combination, just observe the MPN value. So MPN value from the calibration chart is 96. So I will simply write down final MPN value is equal to final MPN value is equal to MPN value from the calibration chart, which is 96, multiply by, now come to the dilution of this calibration chart. The dilution of this calibration chart is 10 ml, 1 ml and 0.1 ml. So the first dilution of the calibration chart is 10 ml. So I will multiply it with 10 and I will divide it with the first dilution of test performed. So this is the first dilution of test performed, which is 0.01. And now this will be my final MPN value that I have to report in the examination. Most of the students, they simply report this value and that is totally incorrect. Okay. Whenever you have the MPN question, definitely the dilutions that you are performing and dilutions of the calibration chart may not be same. For other exams, it can be an easy question if both the dilutions are same. But in GATE examination, definitely the dilutions will be different. So this will be the final MPN value. What is the answer for this? Final MPN value will be how much? This will be, I think, 96,000. That will be the final MPN value. 96,000 will be the final MPN value. Very good. Very good, very good. Chalo, let's move ahead with this. Okay, now next is the treatment of raw water. My dear, the treatment of raw water is either carried out by screening, means the treatment of raw water is carried out using screening, aeration, coagulation, flocculation, then sedimentation, then you have filtration here. So there is one more term here, filtration. Filtration, and then you have softening and disinfection. First of all, screening is used to remove coarse suspended solids. Screening is used to remove coarse suspended solids. We know that majorly two types of screens are there, coarse screens and fine screens. And in the water treatment plant, we use coarse screens. Reason is, fine screens get eventually choked frequently. That is why it increases the operational cost, right? So in the water treatment plant, we go with the coarse screens. So first of all, screens removes coarse suspended solids. Screens are placed inclined in order to increase the surface area, which increases the efficiency of screening. Next, coarse screens are used in the treatment. Head loss through the screen increases as more particles clog the void. So over the period of time, the head loss through the screen keeps on increasing. In order to calculate the head loss through the screen, you can use this formula, K upon 2G V square minus U square, where V is the velocity through the screen and U is the velocity of approach. By the velocity by which the water is approaching towards the screen is U, and V is the velocity through the screen. Now over the period of time, as more number of voids will be clogged, velocity through the screen keeps on increasing. And if velocity through the screen keeps on increasing, head loss through the screen also keeps on increasing. It is as simple as that. If more voids are choked, then the area available for the flow will be less. And the area which is available for the flow will experience huge frictional resistance and will offer huge frictional resistance for the flow happening through the screens. That is why also the head loss increases when the flow takes place through the screens. Okay, sir. The second method of treatment is aeration. The process of aeration is bringing the water in intimate contact with the air so that the exchange of oxygen can take place. Exchange of oxygen from air to water can take place. This oxygen helps in oxidizing the organic matter present in the water sample. This dissolved oxygen, this increase in dissolved oxygen removes taste, it removes odor, it removes organic solids, it removes it removes those solids which cause all these things. So I have listed this down. It removes dissolved organic matter, dissolved gases, taste and odor, and color causing compound. Color causing compound was the word that was I not getting. Right. So basically aeration removes majority of the dissolved impurities, specifically like dissolved organic matter, dissolved gases, taste and odor, and color causing compounds like iron and manganese. But my dear, there is one drawback with this aeration. When this aeration is performed to remove, when this aeration is performed, eventually color causing compounds are removed, but the removal of this color causing compound increases the acidity of the water. So that is the only one drawback with this aeration, that it increases the acidity of water. It increases the acidity of water. Now there are 4 different methods of performing aeration. First one is called as spray nozzle method. Second one is called as tray tower method. Third one is called as cascade aerator. And fourth one is called as diffused aerator. Huge amount of cost is involved in developing pressure in spray nozzle method and diffused aerator. That is why these 2 methods are not used to treat community water. These 2 methods are only used for personal use. Tray tower method is the most efficient method of performing aeration. But the area of tray required to treat community water comes out in kilometers even for tier 2 cities. That is why tray tower method is not adopted. It is one of the most efficient method of performing aeration. The last method that we actually adopt to perform aeration is termed as cascade aerator. First of all, my dear, it is the method of giving you minimum efficiency of aeration. Least efficiency of aeration is given by cascade aerator, but since cascade aerator there is hardly any operational cost or maintenance cost, that is why cascade aerators are preferred over all the other methods to carry out aeration. Okay. So this is how the aeration is performed. Next we have the process of sedimentation. Sedimentation is a technique in which we allow the solids to settle under their own weight. No chemicals are added. Simply we make the water so smoothly flow in the tank that the solids will settle under their own weight. The phenomena of sedimentation will be governed by a single factor which is termed as specific gravity. You can understand specific gravity formula, we all know. Specific gravity is unit weight of solids divided by unit weight of water. Or it can be density of solids divided by the density of water. Understand specific gravity from my point of view. How do I feel specific gravity? Specific gravity is the relative weight of the solid with respect to water. Now, if the relative weight of the solid is more than with respect to water, eventually the solid will going to settle. And if the relative weight of the solid is less than the weight of water, then eventually the solids will going to float. So that is how specific gravity works. Specific gravity is the relative weight of the solid with respect to water. So specific gravity is the only factor which decides settling of the solids. There are other factors which decide settling of the solid. First one is the velocity of flow of turbulence, velocity of flow or turbulence. So if velocity of flow is huge or turbulence is huge, then the settling velocity will be affected. And simultaneously, the settling of the solids will be affected, means settling of the solids will be reduced. Due to the eddies produced in turbulence, the settling solids will be again sent back into the suspension. Next one is the viscosity of the fluid. So if viscosity of the fluid is more, that fluid will going to offer more resistance against the settling of the solid. So again, if viscosity is more, settling of the solid will be less. Third one is the size of the particle. My dear, if you are comparing 2, 3 or more particles have made of same material, then only you can comment on the specific gravity, then only you can comment on the settling of those solids. So first thing, while comparing the solids based on their size or settling of the solids based on their size, first thing you need to make sure that all these solids are having same specific gravity. If all the solids are having same specific gravity, then with respect to size, settling of the solids will be affected. Larger the size, better will be the settling of the solids, but make sure that all the solids that you are comparing having same specific gravity. If the solids have different specific gravity, then other factors will be used. Example is, if you sink a feather, right, if you drop a feather in river or if you drop a stone in the river, feather will float over the surface, rather this stone will settle inside the water, okay. Now sir, this comparison cannot be done because specific gravity of feather is different from specific gravity of stone. So no doubt feather has larger size, but still it is floating on the surface, okay. So the settling velocity, when you drop the particle inside the fluid will going to settle under a constant velocity which is called as terminal velocity or settling velocity. The general expression of settling velocity is under root 4 by 3 GD into G minus 1 upon CD. This is CD. GD into G minus 1 upon CD, where CD is the coefficient of drag, G is the acceleration due to gravity, this D is the size of the particle, G is the specific gravity of the solid solids. For laminar flow condition, and if the size of the particle is less than 0.1 mm, then the same settling velocity can be calculated using another expression which is equal to 1 upon 18 gamma W D square into G minus 1 upon mu. So for laminar flow condition, settling velocity Vs is equal to 1 upon 18 gamma W D square into G minus 1 upon mu. G minus 1 upon mu, right? Mu is the coefficient of dynamic viscosity. Okay, sir. Let's move ahead with this. So in order to carry out sedimentation, we use sedimentation tanks which are of two types: horizontal flow, fill and draw type sedimentation tank and continuous flow type sedimentation tank. Fill and draw type is simple. You just fill the water for 24 hours. In that, all the solids will going to settle, and then after that, after 24 hours, you draw the water which is already settled water which is free from suspended solids. The second type of sedimentation tank is the continuous flow type sedimentation tank, which is of two types: horizontal flow type and vertical flow type based on the direction of flow, right? We have done this entire analysis. We know that in horizontal flow type sedimentation tank, there is a chance that even solids which are having size less than the concerned size can be removed. There is a concept of partial removal in horizontal flow type tank. But in vertical flow type tank, there is no concept of partial removal. In vertical flow type tank, only those solids which are having size equal to or more than the concerned size will be completely removed. And for horizontal flow type tank, solids, even some solids which are having lesser size than the concerned size, they are also partially removed. So eventually, horizontal flow type tank will be having more efficiency of sedimentation than vertical flow type tank. Okay, sir. Percentage removal of smaller size of particle can be calculated as Vs1 divided by Vs into 100. The same thing for laminar flow condition can be calculated as d1 square by d square into 100. d1 is the size, smaller size of particle, d is the concerned size of the particle. One more thing here, the settling velocity of concerned size of the particle is termed as surface overflow rate. Okay, here I have written efficiency. Efficiency of sedimentation is percentage concentration multiplied by percentage removal. Then you have displacement efficiency, which says average flow through period divided by the theoretical detention time. So if your displacement efficiency is more, then your short circuiting will be less. But if your displacement efficiency is less, your short circuiting will be more. Means the particles which were supposed to settle, they will move out of the tank without settling, right? So this is what we mean by displacement efficiency. So here I have also written higher the displacement efficiency, lesser will be the short circuiting. Now please try this question. Have 2 minutes of time. In fact, only 1 minute will be sufficient. Go for it. So the question is saying that calculate the ratio of minimum size of particles that are completely removed from the two identical sedimentation tank with surface overflow rate of 25 meter cube per meter square per day and 16 meter cube per meter square per day. Now sir, first one. So there are two tanks, tank 1 and then you have tank 2. Okay. Both of them are the identical tanks. But for the first tank, the surface overflow rate is 25. Surface overflow rate is 25 meter cube per meter square per day. And for tank 2, surface overflow rate is 16 meter cube per meter square per day. Surface overflow rate is nothing but the settling velocity of concerned size of the particle for which this tank is designed. Similarly, this surface overflow rate is the settling velocity of the concerned size of the particle for which this tank is designed. Now from the expression of settling velocity, I can write down Vs is equals to 1 upon 18 gamma W d square into g minus 1 upon mu. So from here I have one conclusion that settling velocity is directly proportional to the square of concerned size of the particle. Vs is directly proportional to d square. So I can have the ratio of this. I can write down Vs1 by Vs2 is equal to d1 square by d2 square. So you can substitute the value of Vs1 25, Vs2 is 16. Taking the root, you will get the ratio of d1 by d2. Get me the value of d1 by d2. Please tell me the value of d1 by d2 quickly. So d1 by d2 will be 5 by 4. What will be the answer for this? 1 point something. Please tell me the answer for this. d1 by d2 will be 5 by 4. What is 5 by 4? Yeah, good evening Richa. Please tell me the answer. What is 5 by 4? Richa madam. What is 5 by 4? Quickly tell me. So that we can move ahead to the next question. So I think this is d1 by d2 will be 1.25. Quickly confirm your answers. What is 5 by 4? 1.25. Yeah, 1.25. Chalo. Next question. Try this. Question says that surface overflow rate of a primary settling tank discrete settling is 18,000 liter per meter square per day. Sir, I will only write down the data first. Whenever I'll see a lengthy question, I keep writing down the data because it simplifies my answer. Very good answer, Richa. Correct. Surface overflow rate of a primary settling tank is 18,000 liter per meter square per day. So this is 18,000 liter per meter square per day. Kinematic viscosity of water in the tank is 1.01 into 10 raised power minus 2 centimeter square per second. So kinematic viscosity nu is given to you as 1.01 into 10 raised power minus 2 centimeter square per second. Okay, sir. A specific gravity of the settling particle is 2.65. So G is given to you as 2.65. Acceleration due to gravity is 9.81 meter per second square. The minimum diameter in micrometer rounded off to 2 decimal place of the particles that can be removed with 80% efficiency in the tank is. Efficiency of removal is given to you, percentage removal is given to you as 80%. You need to find out that size of the particle which will going to give you the percentage removal of 80%. Now sir, how we can do this? So we have one very simple relation that percentage removal is equal to VS1 divided by Vs into 100. Percentage removal is equals to Vs1 divided by Vs into 100. Vs1 is nothing but settling velocity of this smaller size of particle. And what is Vs? Vs is the surface overflow rate, that is the settling velocity of the concerned size of the particle. So first calculate the value of Vs1. So percentage removal is given to you as 80%. So I will write down this is 80 by 100, which is equal to Vs1 divided by Vs. Vs is 18,000 liter per meter square per day. So if I have to convert this into meter cube, it will be 18 meter cube per meter square per day. This will be 18 meter cube per meter square per day. So from here, get me the value of Vs1. So Vs1 will be 0.8 into 18. Please tell me the answer for this. Please tell me the answer for this. 0.8 into 18. So this will be 14.4. 14.4 meter cube per meter square per day. Right. In fact, you are getting a settling velocity which is meter per day. Okay. Convert this into meter per second. So Vs1 is equals to 14.4 divided by 3600 into 24. Means for your understanding, I can write like this. This is 24 into 60 into 60. So this settling velocity will be in meter per second. Now sir, why you have converted this into meter per second? Because beta, here kinematic viscosity is in centimeter square per second, right? Chalo. We know one expression. Settling velocity Vs is equal to 1 upon 18 gamma W d square into G minus 1 upon mu. But instead of dynamic viscosity, they have given kinematic viscosity. So how we can use this expression? We know that kinematic viscosity is equals to dynamic viscosity divided by density of water. Mu by rho W is nu. So you can write this gamma W as Vs is equals to 1 upon 18 G into rho W, G into rho W into D square into G minus 1 upon mu. Now this mu and rho W will become nu. So you have expression of settling velocity Vs is equals to 1 upon 18 Gd square into G minus 1 upon nu. So you can use this expression of settling velocity to find out that size of the particle which will have the settling velocity of this value. So I'll use this. Use this, substitute Vs1 and this expression to calculate the size of the particle. So I will write down Vs1 is equal to 1 upon 18 G into D1 square into G minus 1 upon nu. Substitute all the values. So Vs1 will be how much? Vs1 is 14.4 divided by, so this is 14.4 divided by 24 into 3600. This is equals to 1 upon 18. G is 9.81 into D1 square into 2.65 minus 1 divided by nu. So what is nu? Nu is given to you in centimeter square per second. So you have to convert this into meter square per second. So this is 1.01 into 10 raised to power minus 2. So 1.01 into 10 raised to power minus 2 into 10 raised to power minus 4 meter square per second, right? So now everything is equated. Whatever size you will calculate, that will come out in meters. Convert that meter into micrometers. So do this. So this will be how much? 14.4 into 18 into 1.01 into 10 raised to power minus 6 divided by 24 into 3600 into 9.81 into 1.65. That is equal to D1 square. Get me the value of D1 in micrometer. This D1 will come out in meters. Calculate that in micrometer. So this will be 14.4 into 18 into 1.01 divided by 24 into 3600 into 9.81 into 1.65. Into so D1 will be 1.368 into 10 raised to power minus 5 meters, right? So from here the value of D1 will be 13.68 micrometer. All of you kindly confirm this, whether you are getting the same answer or not. Are you getting the same answer for this? Kindly confirm it. Kindly confirm this if you are getting the same answer or not. Okay, so this is how you need to deal with this sedimentation type of question. So I think the session was planned for 3 hours, and quite effectively we have utilized these 3 hours in practicing so many questions and simultaneously seeing all the concepts. We will continue the discussion in the next session, but before moving ahead, I would just like to make certain announcements for you. And these announcements are related to IMS GATE Academy. The first thing, my dear student, is You will find the link of Telegram group in the description box. Kindly join our Telegram group to have all these lecture PDFs. We post regularly quizzes, so you can enjoy those daily quizzes as well. Simultaneously, we at IMS Gate Academy, my dear, we offer you 800 hours of live teaching with interaction, where we provide you with theory and exercise book containing 4,000 practice questions. And these practice questions are well versed in level 1, level 2 and level 3. Along with that, we provide you with 33 years of GATE question bank, in which we provide you with the detailed solution, alternate solution, video solution, along with key points and chapter overview. We provide you with the flagship program of mentoring, where we are providing 12 personalized one-to-one mentoring session in order to keep you oriented, focused and stayed motivated throughout your preparation journey. We provide you with India's largest test series containing 130 plus tests, is starting from the chapter test, subject test, multiple subject test, advanced subject test and the full length mock test. We provide you with the free counseling session. Again, the link of those counseling sessions is provided to you in the description box. You can book your slot for counseling and you can speak in detail with our education advisors. They will help you out in making a good decision about your career, and eventually you can take a decision and start your journey of GATE preparation with us. From this year onwards, we have launched a flagship program which is termed as Test Series Plus, where we are providing you with India's largest test series along with the GATE question bank of maths and aptitude and technical subjects at a minimum price of 3,299. So you can avail all these features of IMS Gate Academy in one click. Again, you can see there is a continuous one strip which is floating in our screen, which is termed as zero fee program. You can just check on our zero fee program, where we are providing you certain content for free of cost, so that you can make a good decision about your GATE preparation. IMS Gate Academy is a one-step solution of GATE preparation, and if you are a serious candidate, want to excel in your life, definitely we can help you out, especially in the technical grounds. We have kept our students motivated throughout the journey of preparation. Although GATE preparation is a journey where ups and downs happens, right? So many things students read, but we keep them targeted, we keep them focused, and eventually if they lose their confidence, these My Plan sessions are the motivational boosters for them. Because once they analyze how much amount of content they have already read and how much amount of content they want to read in the upcoming days, when you have that kind of clarity, eventually you are in a very good path. And that is what we do at IMS Gate Academy. So this is one such session of GATE Score Booster. We will be coming up of the next session of this environmental engineering on 22nd of November. And we will continue from this point onwards where we have left today. We will start with the topic of coagulation and flocculation, and if some numericals are still there for sedimentation, that also we will going to see, and like that we will continue with our sessions. So thank you so much, my dear students, for staying with me till the end, and especially for 22nd of November, I'll be awaiting for you. I'll literally wait for you so that we can enjoy these sessions, and I can help you out in just preparing these concepts in very less time. So this is all for the day. Thank you so much and have a great night ahead. Thank you.